All right, so the last time, where we ended was the whole, we talked about methods, which are like functions. They're a little different, and at this stage, I don't expect you to be an expert on methods. I want you to be aware of them. And then later in the semester, that's when we're really going to learn about them. But what's interesting about methods is they act on, you don't pass it as a parameter, but they act on an instance of something of some type. So there's a bunch of methods that go with strings, like the ones we saw, that upper, right, capitalize, those are methods, but they act on the string that you call the method on. They'll call that like the implicit argument, meaning you didn't pass, let me show you what I mean. I called this method, and there was no argument in there, right? I didn't pass any value to the method. But it acted on that string, the one I called the method on with that little dot. It's the implicit argument. It's kind of like, oops. It's kind of like if it were a function, you'd call it like this. Okay? But again, I don't want you to be an expert on methods right now. I just want you to be aware that they exist. And if, like I was saying last time, if you start to get worried about how am I going to remember what's a method, what's a function, don't. If you're trying to, you're doing it wrong. No crazy person is going to memorize all of that stuff. You just, when you need to do something, you look it up, and then you do what you see how you do it. Is it a method? Is it a function? How to, and this is how I would do it. String capitalize in Python. All right, Python. I'd click it and see, oh, perfect, there's an example. That's exactly what I need. That's how you would do it. You wouldn't do it by going, oh, I remember it's a method that I can call on strings. If you do, great. If not, you look it up, and in 2 seconds, you'll find an answer. Any questions before we get to the next thing? So this topic was strings, but we can generalize the idea of strings into what we're going to call lists. And you used a list in assignment 1. You had a list of Starbucks locations. A string is like a collection of individual characters in some order, right? The order matters. It's not like they need to be sorted. It's just the fact that H came before E, which came before L, which came before L, which came before O, that's hello, right? The order matters. Well, we have a list here, and a list is a similar idea, except we can have a collection of whatever we want. Instead of a string being a series of characters, a sequence of characters, we can have a list which is a sequence of whatever. So it's more general. So here's some code. Let's just do this together. There we go. So here we go. I've created a list. I can print out the list. I've created a list. The list is 5, 7, 9, and 10. And I put it in a variable called SumList. I printed out the list. Okay. I printed out the list at index 0. I got back the thing at the beginning, 5. I did that slicing thing. I printed out the list from index 1 to 3 exclusively, meaning we just didn't include the 3, so it's 1 and 2. So we see 7 and 9. And then I asked what the type of what's in that variable, and it's a list. There. Nothing too crazy. It's very similar to if it was a string. In fact, I'm going to be bad and just say, you know what, make this a string. That's what we get, right? We could do the same thing with strings, except here, you know, we're working on a list. Well, this is the string, but now it's the list. So what types can be in a list? Well, all right, clearly I can put integers in there. Can I put, can I mix types? Looks like I can. Can I add a string? Yep. Can I have a Boolean? Yeah. Can anyone think of any other type we know of? None. We could throw none in there. Why not? Any other type that we've learned about recently? Another list. Whoa, wild idea. Yeah, we could do that. We could put a list in a list. But can we put a list in a list in a list, do you think? Yeah, of course we can. We can have a lot of fun. So we could put a bunch of different types in there. And yeah, we can clearly have things of different types. And like strings, we can actually index the list backwards. This is a Python thing. Get the last thing with a -1, which is actually that whole list. So don't be confused here. This is a list inside of a list. So this list has 1, 2, 3, 4, 5, 6, 7, 8, 9 things in it. Because that last list, although it contains 2 things, the list itself is one thing that contains 2 things. So the last element in the outside list is actually the whole list, A, B, which is interesting to note. Can we find the length of a list? Well, we can, just like we did in with strings. Yeah, it's 9. Perfect. And we can, of course, like remember with a string, I could make a string. Right? I printed out A, and I asked what the length of A is. Well, A is the string of nothing, so we don't see anything. And then we printed out the length of A. Well, it's 0. But it is a string, and we can verify that by saying, what's the type of A? So it is a string. There's just nothing there. It's empty. But it is a string, and it has 0 length. I could change this to a list, have an empty list. The empty list we printed out, well, there's nothing there. Here it's represented as an open and closed bracket because that's how we represent the list usually. Its length is 0, but it is a list. It's just there's nothing in it. So there's nothing wrong with having an empty list. Here's if I have a list, I'm going to show you something kind of neat real quick here. A, B, C, D, right? I can actually append something to a list. So if I want to actually like add something to the end of that list, I could say, okay, A dot append E. There, right? So I had the list A, B, C, D, and then I appended to the list A the letter E. I print out A. We can clearly see E is there. What would you call that append right there? Is that a function? No, what do we call it? A method, because we ran it on an instance of something. I ran append on A, and A was holding on to an instance of a list. Okay? So it's a method. Methods are going to pop up more and more. So there we go. But here's a weird one. What do you think is going to happen if, like, maybe I don't append A, but I append A to A? Here's a wild one. Take a moment. What do you think that code's going to do? Add a list. What list? But what's A? A is a list. Oh, let's see what happens. Huh. Okay, hold on. What is A at index 0? It's A. 1, B, 2, C. What's A at index D? Not D. What? 3. What do you think it's going to be? Okay, so far so good. Now we're appending A to it, meaning that there is something at index 4. What's going to be at index 4? No, the whole list. But wait, well, hold on. Hold on. Wait a minute, hold on. Okay, let's do something real quick here first to make sure something makes sense. If we have A equals 0, 1, 2, and then inside of it we have a list that's like 11, 12, 13. And then inside of that I have a list that's like 5, 3, 1. I don't know. Print A. So now here I have a list that actually has a list inside of it that actually has a list inside of it. So let's look at what happens when we index this list. So A at index, I'm actually going to make this a little shorter for the sake of brevity. A at index 0 is 0. A at index 1 is 2. What's A at index 2? Well, it's actually all of this, that whole list. Because that's what came after 0, 2, and then it was that whole list. And then you might ask, well, what if I want to index that internal list? Well, the good news is A at index 2 is just a list. How do you index lists? With the square brackets. So A at index 2 at index 0, what do you think I'm going to get? 11. 12. 13. What do you think I'm going to get when I do 3? Yeah, that last inside list. So the A at index 2 is this whole list. At index 3 is this whole list. And then if I want to index that one, well, I just index that one. That's how I get the 5. It's kind of wild, right? So I can index the lists. And if you're like, whoa, hold on, slow down. No, you're going too fast. I'm not going too fast. You're looking to connect dots that don't exist. We're just following the rules that we've learned so far. I've not showed you anything wild or crazy or new. I'm just showing you what you can do with the rules we've learned so far. So back to this crazy thing. A at index 4, well, what's A at index 4 at index 4? A at index 4 at index 3 should be the D. Index 4. Looks like I could just kind of... It looks like I've got this weird like loop thing going on here. The thing at index 4 is the list itself, which is kind of wild. When you think about it, really what we've got here. And this is actually a bit of a hint onto the next topic. Really what I have here is A, B, C, D. I have A. Can you see that reasonably well near the back? So. Well, next time sit closer. It's your fault, not mine. We have A, B. This is a really squeaky marker. You can't see anything? All right, that's not, maybe it is my fault then. Is it better or worse? It's worse? Maybe I got a better marker in here. Give me a second. All right, that's no good. That's pretty good. We'll hold on to that one. We'll see if we can find a better one. That's pretty good too. That's okay. Red's pretty good, it seems. Let's try this again with this red. I have A. Is that better? It's still pretty bad?
I'll go with the second option that you used.
Pardon?
Go with the second.
The black one?
Yeah, that was good.
All right, let's give it a go. I think it was this one. I'll have to go all the way over here now. A. Can you see that? It's good? Yeah? All right, good. This is supposed to be an A. I can't draw big A's, I guess. And we have the list A, B. The previous prof left all these little ticks all over the board. Oh, my goodness. C. I think there was a D, right? But then I appended something to the list. And I appended A. But when you're looking at this picture, that's an arrow, okay? When you're looking at this picture, what is A? All right, hold on. I heard different answers here. So I heard, okay, it's the entire list. I heard something else. Who said A is the list? A is the list, so it's kind of the same as in, someone said something else. It like points to the list, that's what you were saying, yeah? I mean, kind of, yeah. I mean, A is like this list, but A is like, you know, it's this list. So really, like what I've got here is kind of like that. That's kind of what's going on, really. Now we're going to hit this a lot harder, I think, in the next topic. But that's, you know, kind of the idea of what I just did there. Say that again? I think the 3 dots are Python being like, screw you, I'm not writing everything out. Because it'll just go on forever, right? Because otherwise it would be A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D, and there would be no end. So I think this is Python's way of being like, look, this is all I'm doing for you. Yeah?
I think it kind of points to the list because if it was literally the list, it would just append like the one instance of the list instead of being infinite. You know?
Yeah, and you know, this actually connects back to that problem of, you know, if I've got a single variable, I can, you know, like a single integer, I can put the integer in this spot of RAM and have a seat. But a list is funny, right? I can't shove a whole list into one seat. So I got to do something. I got to get creative there. Hopefully. All right, anyways. So data structures. When you're learning programming, you've got your algorithms and you've got your data structures. The name data structure should be pretty self-explanatory. It is some structure of data. Here, we're talking about a list. A list is a data structure. It's a place we can hold data. And we can access that data pretty easily. We can manipulate the data pretty easily. But algorithms and data structures go together like this. And there are a lot of different data structures. To solve a given problem, if I choose to use some data structure, I might have to write my algorithm a certain way. But if I choose to use a different data structure, that could impact how I write my algorithm. But lists are our first data structure. Here's a quick one. We did linear searches on strings. I want you to do a linear search, but in a list. I'll give you 4 minutes to do that. Right? Remember that we did character is in, right? And then it returned a Boolean with needle and haystack. I want you to do that again, but with the list. See if you can do that. Give yourself a few minutes. Raise your hand if you're done. Raise your hand if you're done in like 1 more minute. Take the minute. Here's mine of the first one. Let me turn this off. Contains while. In fact, this code's going to be exactly the same as the one on the string with the while loop. The only difference, yeah? Is there a mistake?
Shouldn't you increment index?
Of course I should. This is obviously not going to work, obviously. I was testing you, totally. No, I made a huge mistake. I forgot to increment index. This will just run an infinite loop. Shoot. Look what happens when I don't test my code, right? There. Now it should be good. So the only difference between this code and the one that I wrote for the string is the variable names. Otherwise, it's the same, right? I think in the other one I called it like character index. Other than that, it was the same. Because a string is just a linear collection of characters. A list is just a linear collection of whatever. So this will work, assuming you can compare the things. So yeah, if I find it, return true. If I ever get to the end, meaning the loop's done, and I never found it, well, I must not have found it, therefore it's not there. So here it is. Now we'll skip the other ones for now because we get to them in the topic. But are there any questions about this? All right. So here's just a little quick thing. This is not going to be exhaustive. I'm just showing you that you can do it. You can concatenate strings together. Here's one, some list, 5, 6, 7, 8, 9. Some other list. This is a list. You can concatenate them together just like strings to make a new, bigger list. Now, some list and some other list are left alone. But the new list, the concatenated form of it, is stored in bigger list. Let me show you what I mean here. Right? Some lists and some other lists were left alone, but they were used to create the bigger one. The concatenation made a bigger list, a new bigger list, that was stored in bigger list. You can also multiply a list by a number to make it repeat itself as many times as you want. Just like you could with strings. Yeah. And we'll skip that activity, but just like there were a bunch of methods for strings, let's have a quick look to see look at this. Append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. I wonder what reverse is going to do. Oops. I guess this doesn't return it. Interesting. Looks like this is a mutating method. There. What did reverse do? I saw like a bunch of people go, yes, you're absolutely correct. That's what it did. But here's something interesting I want you to note that you might hate, but deal with it. Remember with like the strings, because strings are immutable. So when I said like my string dot upper, it left the original string alone. But it returned a new string that was the uppercase version of it. All right? Here, bigger list dot reverse. The reverse method actually did not return anything. When I printed it out, you saw it said none, right? That method didn't return anything. It actually modified, or in programming we'll call that like mutated. But it modified the contents of bigger list. It didn't return a new list that was in reverse. No, it actually took that list and reversed it. And if you say to yourself, how was I supposed to know that? Let me put it this way. I didn't until I tried it and was like, oh, I guess, yeah, it was a mutating one. So don't worry too much about how was I supposed to know it was going to be like that. You weren't until you try it, or maybe you look it up and then you remember that, okay, it's a mutator. So what I mean by that, along with the whole thing about memorizing the difference between function and methods, how am I going to memorize what's a function and what's a method? And like, we'll know the difference between the two, but if you're worried about memorizing what methods exist and what functions exist, don't worry too much about it. Obviously become familiar with it as you get more experience, you're going to learn these things, but don't worry too much about memorizing this stuff because only crazy people do that. Remember, programmers are lazy. We don't remember anything, we just look it up when we need to later. So just like I did here. I tried it, I ran it, saw it printed out none, so I was like, oh, it must have been a mutator method. It must have mutated the list itself. And if that bothers you, that like, well, how am I supposed to know that? What if I want to use it and I mess up? Well, try it, take the 2 seconds to try it, and then deal with it, right? Any questions about that? So don't worry too much about memorizing this stuff. It's not going to happen. I haven't done it. No one does. The only way you would is if you use this method like every other day, right? And you just remember. Okay, mutability. We just talked about this. Actually, before we do that, let's have another quick look. What other methods we got? I wonder what index will do. Well, let's see. Return the first index of value. All right, so is. Six. Why? 0, 1, 2, 3, 4, 5, 6. So this is kind of neat. There's a method for lists where I can actually find out what the index of that thing is. Now, mind you, if you think to yourself, oh, that's great, now Python can do this without having to do a linear search. Well, no. How do you think that that method index worked? If you go look at the code for that method, it's going to have a linear search in it, right? All right, mutability. So remember how with strings, right? And then it's not going to work because strings are immutable. I've got the string, hello, the variable a string knows about it. I index a string at index 4, and Python's happy to go and give me the character at index 4 of that string. Oh, well, there's an issue there. It's going to be mad because of index out of bounds, not because of immutability. I had the wrong bug. There. Now it's the right bug. Now I'm saying on line 3, okay, go to the string at index 4 and change what's in there. Let me take a step back and make sure something is abundantly clear. Is it raining that hard? Is that rain I hear? Damn. Wish I brought my umbrella. Right? I can do this. I can change like what the variable has, but what I can't do is I can't go into the string, hello, and change something about it because the string is immutable. So I could say, hey, variable a, you contain the string hello, and now, oh, no, you contain the string world. It's happy. But I can't say, hey, variable a, go to the string that you have at index 4 and change something about it. There's a very important difference, and it might sound like a nuanced difference, but it's really not. It's a pretty big difference. Right? So the string is like this object, and I can go to the variable and make the variable reference another object, but I can't go to the object and change something about it. With strings, lists, on the other hand, are mutable, meaning this won't work. But if I have a list equals Lists are very happy to do that. I can go to a list and change the contents inside the list. Lists are mutable. Now, I know last time I was saying you might not like the immutableness of strings, but it's actually a really good thing. It helps protect against making mistakes. It's easier to understand and make your code a little bit more predictable. And now I'm saying, but lists are mutable. But data structures, the point of a data structure is for that easy, quick, and dirty access of storing data and accessing the data for whatever we need. So they're built, a lot of times they're built around the idea of being mutable. Even though we like immutability, we all know, like, well, with data structures, we like mutable. So that's pretty cool. Here we go. For loops. They worked on strings, they're going to work just fine on lists. Because the for loop likes to work with for each thing in some collection of things. The collection of things could be a string. It could be a list. But the things will be different, but that's fine. The for loop is great for iterating over each thing in a collection of things in order that they appear. So the first time through the loop we see hello, and then 10, and then true, and then 100.001. Because that's the order they exist in the list. Yeah. And that's what you were doing in assignment 1. You had a list of Starbucks locations. You iterated over that whole list, starting at the beginning, and you went to the end. Now, range. Here's a little bit of a twist on your for loops. Now, in Python 2, it was a lot more obvious. But first, let me show you something. There. This range right here is a great way to say, run a loop 10 times. All right? I said range 10. So I will start at 0, 1, 2, 3, 4, 5, and so on. You can even get fancy. You can say, well, start at 5 and go to 10. So you can actually specify where to start and where to end. And you can also specify how much to count by, which is kind of neat. But going back to the simple one, we've got this. For I in range 10. Cool. So now I have a way to run a for loop really easy, some number of times. It's even easier to do it this way than it is with a while loop. Remember, a while loop would be great if you just use a while loop with a counter if you wanted it to run some number of times. Well, now you can do it really easily with a for loop. But if you're thinking for a second, and now technically in Python 3 it is a little bit different, but let's go back in time 6 years, or maybe a little longer. This would be like I had this. Right? And if you don't like that, remember, sure, I put a literal in here, like the literal list. Right? It's like that. Right? Except I wrote range. But in Python 2, when you said range 10, well, that was like a function that actually gave you back a list that said 0 through 9. So it was doing exactly this. It was just syntactic sugar to make it a little easier to do. So don't think that this is an entirely new type of for loop. No, not at all. Really, you are just iterating over a collection. It's just range. Technically in Python 3, it's returning an iterable object. It's the whole thing. But really, it's the same idea. It's just range is kind of giving you that collection of things quick and dirty to make it easy to loop over just those numbers. Any questions about that? We're happy with it, unhappy with it? I'm seeing one thumbs up. I'm going to assume everyone agrees with you. All right. Da-da. Yeah, see if there's anything I'm missing. So this would be the same idea with a while loop, right? But what's a little nicer? Well, this is less code, right? So it's nice. It's a little more, perhaps, it's succinct, it's clear, it's nice. There's less like overhead boilerplate code I need. But remember, while loops are more general. They just loop on some condition. And this is an example of one way to use a while loop where it's counting. So a for loop, yeah. Okay, any questions? So here's one. Write a function beer on wall that prints out n bottles of beer on the wall for all n. Of course, I don't want you to write n bottles of beer on the wall. I want you to say how many there are, right? For all n from 99 down to 0, the function must use a for loop with the range function. The difficulty here is you got to count backwards. Take a couple minutes, have fun with this one. There, I made mine sing the whole song. Who here got it working? Who here got hung up on, how do I make it count backwards? Well, yeah. Now, I actually did show you this before, but it was with slicing. You just specify the starting and ending index. But the problem is, if I were to just look at range, I said start at 99 and go to 0. And whenever you use something like range, it always is exclusive. The starting index is inclusive, the ending index is exclusive, meaning the way I want it to go is start at 99 and go to 0, but don't get to 0. Stop right before you get to 0. But the problem is, this is saying start from 99 and generate like a list of all subsequent numbers that go up to 0, like from 99 to 0. So, I mean, how many numbers are there bigger than 99 before you get to 0? There's none, right? There are no numbers bigger than 99 but are less than 0. That's not a thing, right? So the problem is, how do I get from 99 to 0? Well, the trick is, I got to count by -1. So I start at 99, I want to go to 0, and I'm going to count by -1s. Then it's happy to do it. So there's my code. For I in range 99 to 0, it'll never actually get to 0. And count by -1s, it'll work. And then once it's done, once it actually is at 0, it prints out sadness. So there's mine. Did anyone do it any like wildly different? No? All right, I'll see you later. Have a great weekend.